The progress being made with image and video models is staggering. AI is really climbing out of the uncanny valley. People and places can be hyper-realistic. Text can be rendered with high accuracy, and they can even do hands with the correct number of fingers now. But what about cost, scale, matching a specific style? To really control your models, you'll want to fine-tune them. So in episode 78 of Tool Use, we're joined by Greg Schoeninger. He's the co-founder and CEO of Oxen.ai. We'll cover what the possibilities are for modern open source image and video models, how you can fine-tune your model for just $1, and how you can prepare your datasets for the absolute best results. So please enjoy the conversation with Greg Schoeninger.
So Oxen is solving the problem of the full AI lifecycle. So everything from how do you manage the training datasets to the model weights to training to inference, and then keeping that flywheel going of collecting data, training a new model, deploying the new model weights, and then collecting more data. And when we started the company back in 2022, this was like pre-ChatGPT. So I feel like the whole industry kind of took a hard left to, oh, we're prompt engineering. We're playing with this new large language model that has all these fancy bells and whistles. And I'm kind of seeing it start to trend back for certain use cases. If you need a really small, fast local model, or if you need something that's super highly accurate in your domain, you can really break out the power tools and optimize all the way down to the weights with Oxen.ai. And so it's fun to kind of see that bounce back and forth and see who's doing what where in the stack.
Would you mind going into a little bit of detail about the situations which would lead someone to want to take that leap from context engineering to fine-tuning? Like what's the threshold people tend to hit?
Yeah, it's actually been really helpful for us to even to have people get up and running APIs just to get a feel for like what AI models can do and what they can't do. And usually it's when they run into, hey, I can't keep shoving all of this into the context window because either there's context rot or it starts to get really slow, or, and slow could be latency. It could be just the pure API overhead to make the request, or they're running into like just straight, this wasn't in the pre-training data. So even any level of prompt engineering won't get you the results you need. And interestingly enough, LLMs are getting really good at the context engineering. You can get pretty far there, but when it comes to vision models, like vision language models or generative image, generative video models, those are much harder to prompt engineer your way out of a problem because a picture is worth 1,000 words. So we find the fine-tuning really takes hold in those more visual domains.
And I'd actually like to talk a bit more about that because a lot of my world, when we interact with the either image generation or video generation, it's fun one-off things, but we're starting to see it become more and more prevalent. So are they ready for prime time? What's the current state of these image and video generation models today?
Yeah, they're getting really good out of the gate. I would say it's still very much of a dice roll what you're going to get out the other end. So if you're trying to do anything that requires consistency over time, so like imagine you're making a 30-second commercial spot and the car changes every time because you're just like prompting red Mazda or whatever, that can be a problem. That's started to be solved with some of these models like Nano Banana or some of the video models like the Kling models or LTX2 that can take in a reference image as kind of like the first frame and then extend from there. So that's like the equivalent of prompt engineering in image or video land. But you still have this inconsistency as you're trying to complete the frames if you're doing video, or this kind of dice roll property if you're doing images. Yes, it might take the reference image and nail it, or it might look like a really crappy collage cutout of your image into the other scene because it didn't really match the lighting or anything like that. So we like to describe it sometimes as like, yeah, it's kind of like you have somebody drunk on your team making the videos, and like sometimes they nail it and sometimes they don't, and it's a lot of vetting to get these out of the box models to do what you want. And so that's where we come in and help some of these customers like train a model specifically for a car, like, a Subaru or something like that. And they have a very high quality, right? They can't have the car look any different in the first frame from the next frame, and they have to have the wheels work well, and they have to have the reflections of the scenery. And there's just like all these things that traditionally you would do with a real photo shoot, or you would do with a giant VFX team afterwards. And either of those directions are super costly, right? For the real shoot, you have to go out into the world and like rent out the street that you're gonna film on, or just like hope other cars aren't going by, or you might have to rent out like an actual virtual production set where you have LCD screens like all around the car, and that's how you're kind of getting the reflections. So a lot of brands, we're based in LA, so a lot of Hollywood folks are starting to experiment with where can we apply AI? Where are we cool with this just like dice roll shot in the dark? Maybe we'll get creative with it and it gives us a shot we never thought of. And where do we actually mix that with real world shoots? And I'm happy to talk about like both of those angles because I think they're pretty interesting.
One quick question before we get to that. One aspect of this that I have found people have brought up is that one of the theories we don't have a cursor for design is because we really want specific, highly like exact tweaks when we get an image output. With prose or any type of writing, it can be loose, it can be fluid, but if you say, for example, I want that Subaru to be red instead of blue, if it regenerates the car in a different position or whatnot, there's issues. So are we starting to get closer to those granular level changes being more accessible, or is it still kind of, like you said, roll the dice for pretty much any tweak you want to make to an image?
I'd say for a lot of the stuff that I'm seeing, Nano Banana, it's getting pretty good, but pretty good is like, depending on the use case, it could be 1 out of 10 it nails, or maybe like 50-50 it nails, depending on how hard it is. So if you're doing things at scale, that doesn't work. And if you're trying to like really automate an end-to-end workflow, a 50% error rate doesn't really work. That being said, that's a great place to land if you are a foundational model company, because now you can start bootstrapping your reinforcement learning loop with those shots on goal. And if you have some sort of, human feedback or maybe language model as a judge, you can start bootstrapping the data flywheel to like make the next iteration of the model better because it's got one good thing out of the 10 to latch onto, and we want to do more of that. So I think we're in the kind of early days there, and the next iteration of the model and the next iteration of the model is just going to get stronger.
Yeah, and in leveraging these models to help with that data flywheel, like you said, it's so many people don't realize that we're not just moving the progress forward, but we're accelerating simultaneously, because every model makes the next one better, makes the data sets better to train, and it's just compounding. It's so exciting.
Yeah, totally. And just to like dig more into some use cases where I've seen customers try to scale up these workflows. We actually had, you mentioned like turn the car red. We actually had a big product catalog use case where they needed to generate 1.2 million images of a product catalog. And they had very specific color codes that they needed to use, like a color palette. And they experimented with like ChatGPT, Image Gen, GPT 1.5 or whatever it's called, Nano Banana, and like even giving the exact color code to it to be applied. So it'd be like the drawers on the desk need to turn blue, and the surface of the desk needs to turn granite black or something like that. And these companies, it has to be the exact blue. It has to be the exact granite black. And trying to just prompt your way into that, you get this variability that is just not acceptable. But if you start to collect a training data set from these models, and it is hitting 1 out of 10, 5 out of 10, and you're like putting those away on the side, and you have this like big automated process that you have to scale up, that's a great way to tackle the problem. And one, it gets you your training data set pretty cheaply. And then 2, it just makes that specific task super cheap and efficient. So I think if you were going to run this 1.2 million image workflow with Nano Banana, one, it would take about 60 seconds per image, which you can do the math, but that's going to take forever. And Google's not going to let you scale that horizontally. You're going to be rate limited. And each generation is in the like 30-cent range or something. I forget the exact number. We could look it up, but it would have ended up being $50,000 to $60,000 to generate that whole product catalog. They ended up fine-tuning this open source model called Qwen Image Edit and cranked through all the data faster because the model that you can scale horizontally, and it only takes like 10 seconds per generation. And the whole project cost $5,000 instead of $50,000. So that's like a 10x speed and 10x cost and like 100x speed to get you what you need, which I think people don't really rock that sometimes when they're like, oh, Nano Banana solves everything. It's like not at scale.
I'd love to dive into this data set aspect because I love the idea, you go on Nano Banana, generate some images that are to your liking, start curating that set, use other images, even, manually edited through Photoshop or something, just get that core data set. When we're looking to fine tune a model, and I'd like the answer for both image and video, how many entries to the data set do we need? Do we need a certain type of quality or resolution? Like, could you just give some insight to what people should like strive to build before they start fine tuning?
Yeah, it's interesting because you can start seeing results with a pretty small data set. So anywhere from like 20 to 30 images, you'll start to see it pick up the style, or pick up the character, or pick up the color that you need. And then it really just depends on like how many variations of that thing you need. So in the case of the color coding example, there were 16 different colors that needed to be captured by this model, and then like every different combination of that. So they gathered about 100 examples in each color palette, but not every combination of them, right? So it would learn, this is the blue that I mean, and when I say apply it to the drawers, this is what I mean by drawers, this is what I mean by frame, etc. So it can kind of learn each individual concept with that 50 to 100, training data points. And then what's awesome about these models is then it can start combining the concepts for you. So at the end, you get something that can do all the different permutations just from that little training data, because the model's been pre-trained on a ton of instances.
That's super cool. And for that data set, when you say like teach it what a drawer is, how does the data labeling process work? Do I have to go in and say, for this image, these are the attributes I want to capture? Do I have to describe it in detail? And for video, is it frame by frame, or like for the clip, do I just do a single tag? Like how do I annotate the data?
It depends on the type of model. So the simplest image generation model would just be like a prompt and an image, and then you just create a bunch of pairs of that. A more complicated image gen model might be like, they call it image editing. So you would have an input image and then an output image and a prompt. So you would kind of have 3 columns. That one's a little more tedious to collect because you need to have the reference image and you need to have the transformation that needs to be done. And then for video training, it gets even more complex because you have a lot of different ways that you could organize that data set. And so the simplest one is actually just using images and prompts again. And that's going to get you things like, pretty much what you're doing is the video generator is generating frame by frame. And so it could get a character or a style into the scene just from a single frame, but it won't capture things like motion or animation style or things that need to change over time. So in that case, what you want is actually like 5-second video clips and a prompt associated with that 5-second video clip. And then to add another dimension to it, you might have audio. So you might have the video and the audio, which you could have in one file, but then the prompt needs to be pretty specific on, this is what I want to direct in the video, and this is what I want to direct in the audio. And that's kind of the magic secret sauce of a data set, is the prompts themselves. I kind of use as a frame of reference is whatever I'm captioning during collecting the training data, I want to be able to direct later. So like if I want to be able to change the color of something, then I need to make sure that I have the color in the prompt so that it can learn to change the color. Anything you leave out of the prompt, it's just going to like learn inherently because it's like, oh, you didn't tell me anything specifically there. So I assume that every image that comes out the other end should have this property. So like if you were training a character and the character had red lipstick or something like that, if you don't say red lipstick in your training data, it'll just like bake that into the model weights. And then everything that comes out will always have red lipstick. So if you want to be able to direct that later, you have to make sure that you kind of capture it in the training data.
Is it at the point where it requires a human's insight and like descriptive ability in order to annotate it? Or could I theoretically put together a pipeline where like video in, feed it to Moondream, it describes it with the criteria I want, creates the data set, and then feed that into the model? Like, can we automate more of this process?
Yeah, that's actually the first step that most people do. And honestly, the pipeline we take you through in Oxen just to get your like first fine tune out is you just like drag and drop a directory of images or videos. And then the next step is auto caption. We use like Gemini 3 or kind of choose your own model in there. And we have a pretty good default prompt for you, but then you could tweak that to extract whatever you want. And then you just click run. We'll go run that in parallel on all the data and get you the first iteration of the training data set. I would recommend, especially if you're in the like 50 to 100 example, go through and look at all of them. And honestly, once you look at 10 to 20, you'll quickly realize you left something out of your prompt or you wanted more detail or less detail. And then you can go back to that prompt engineer the visual LLM to relabel the data. And that's the workflow that I usually go through.
It makes it so much more accessible than what I think most people, myself included, kind of had envisioned. One thing, I'm sure you get asked this a lot. If, like, as you mentioned, you can train it on something like color or style, can you do both? Would just need to mean you increase the data set to have all these different permutations? Like, could I do a character and a style and color and just fine tune all of that into a single model?
It depends on the types of things. Sometimes I've seen them blur the lines. So one thing that you need to make sure you do is like, it's helpful to have a special token for that thing that you want the model to like learn the association with. So even if you're doing a character, you might like spell the character's name weird or something. Like you might say like, what's a good example? Like Charlie Brown, you might have it all capitalized and then the E's are 3s and like an underscore, so that's like a very special token in your data set that during training, anytime it sees Charlie Brown, it like maps to that token. And if you have separate concepts or separate characters, it makes it easier for the model to latch on to like that specific token or word as you're training. That being said, for characters specifically, I do see a lot of bleed in between concepts. So I trained a model that was just like playing around and I was trying to see if I could get Will Smith on Conan O'Brien and them just having a conversation back and forth with each other. And the first couple stabs at it, it would just generate Conan or just generate Will Smith, or it'd be like this weird mix of them, which you can imagine what that looked like.
Yeah.
And so what people do in like a professional setting there is these video models, some of them have finer grained control that you can put in to the prompt. So, like in traditional VFX, you have a thing called a mask that's just like a bunch of ones on one section of the image and a bunch of zeros on the other. So it looks like white and black. And you can mask out the region that you want to apply this LoRA or this set of trained weights to. And then you like do one pass on Will Smith just to like paint in his pixels. And then you do one pass on Conan to paint in his pixels. And then that one, it keeps the rest of the scene the same. And then 2, you don't have that bleed going over each individual character. And there was one project that we were helping with that trained, I think they said over 90 different LoRAs for the project. And it was a music video with David Guetta and Dimitri Vegas like driving these crazy motorcycles through a fictional apocalypse. And, they trained a LoRA for the face of David Guetta, for what he looks like. They trained a LoRA for the face of Dimitri Vegas, for the singer, for the motorcycle, for the robot that came in the scene, for the dinosaur, for like all these different things, all the way down to the way that the hair blew when they were on the motorcycle, because the models couldn't do that out of the gate. It like had no idea how human hair flowed naturally on a motorcycle. That data set was there's like a bunch of videos online of people making, when you like blow a hair dryer in your face and just go, and it just like fills your cheeks. That's where a lot of that data came from. And then they just like masked out the section with the face and just captured like what hair moves like in the wind. So it just kind of unblocks you when you run into one of these foundation models and it's like, it can't do this thing, or it can only do this thing 10% of the time. If you run into either of those scenarios, you can kind of unblock yourself and make it do anything, which is pretty awesome.
I do want to get back to LoRAs, but just one thing before I forget, thinking about that automated pipeline, would something like Meta's SAM, the segment anything model, work well for that type of isolation within a video, like just another step in the pipeline?
Yes, 100%. Segment anything 3 is really great at video, and you can just put in a prompt of what you want to segment out, and it'll segment that out. And I almost guarantee that the foundation labs are like using that in their pre-training data now to bake this right into the model, so that the next model release will be like, we can do this out of the gate without a LoRA, because it just understands the concept of a mask.
But okay, for LoRAs, so could you explain the difference, or what situations you prefer to do a full fine tune versus a LoRA? And just like, the pros and cons to each approach.
Yeah, definitely. So a LoRA is just this little set of adapters that you can plug onto the model, and it has a specific size or like capacity you can almost think about there. But then the base weights of the model stay the same. So neural networks have this property of like catastrophic forgetting when you're training them. So if you train them on more things over time, it tends to forget the things that you taught it at the beginning of the data set. And so either you need to like intersperse a very diverse mix of data while you're training, or you want to like freeze those weights and introduce a new concept through a set of adapter weights. And that's why LoRAs are pretty powerful, because they're kind of this plug and playable set of weights that you can apply to your initial weights, and you can apply them to very specific layers. So you could just target like the feed forward layers, or you could just target the attention mechanism, like the keys and the queries and the values. And so they kind of give you this plug and playable framework. They're also much smaller if you're doing a bunch of experiments. So imagine you did like 10 training runs at once, and the model weight itself for like Qwen image, I think it's like 60 gigabytes for that set of model weights. So if you did 10 experiments with a full fine tune, that'd be 600 gigabytes of data that you have to store for each one of them, because you're like updating the whole model. For LoRAs, it can get down to like 50 megabytes, 100 megabytes, something like that. So you'd only have like 1 gigabyte for those 10 experiments. So those are a lot of pros for LoRA. A con would just be you can't really get all the way down into the model weight. So if you have like a really big data set, it might be worth doing a full fine tune. But I tend to think of that more as like continued pre-training, or they call it mid-training now. So yeah, that's kind of how I bucket those.
A pro I've heard in the past with LoRAs is it's more hot swappable, so you can more easily change from one to the other. In terms of writing, if you want to set a certain personality. A negative I heard is just because they're small, you can only give it so much intelligence within that little bit. So if you want to try to fine tune it on, like you said, a massive change or a lot of context, the LoRAs just don't have enough capacity to really hold it all.
Yeah, that's a really good way of thinking about it. And in the language modeling sense, like I wouldn't expect a LoRA to learn a new fact. For example, it's probably just going to shift the style or the format. Like you could totally do like a if you had a very specific DSL or JSON or structured output that you wanted to get, a LoRA could for sure capture that, but it's probably not going to change the model's opinion on who the president of the US is without a lot of other data,
Okay. One thing I'm curious about is the terms of like tunability of a model, and if there are some that are better than others. One example is I've heard mixture of experts, MOE models are inherently harder to fine tune versus just a more standard dense model. Does something apply similar to image and video? Are there some models that are just crushing it and you can just really make it your own, and some are just more finicky, or are the rules different for these type of models?
For one thing, the mixture of experts in video and image models are sometimes set up a little differently, and they use the term mixture of experts, but it's actually not quite how I would think about it in language models. So there's this model called Qwen by Alibaba, and it was like the state-of-the-art open source video generation model for the longest time. It is still really popular. It might still be like top 1 or 2. And they actually have a mixture of experts where it's 2 kind of identical models that run back to back. And the first half, in theory, is focused more on like seeing and setting and, orientation of things in the shot. And then the second half is really focused on like finer details and, down to the text on the background or whatever. So they have like 2 different networks that run back to back that chain together. And what's cool about that during training is you could turn one on and turn one off. So you could like just apply a LoRA to the front half and be like, I actually really like the cinematic like lighting and touches that happen at the end of the model, but it really just doesn't know my character at all. So I'm just going to like focus on what it's wearing, where it's sitting, how it's moving, and then like keep the second half the same. So that's cool in the video model space. And then I do think there's some models that just landed in like a better latent space than others, like the Qwen series of language models. For whatever reason, maybe they were trained on a lot of the test sets, but also they just generalize better to things that I've seen downstream. It just feels like they landed in a better space than some of the llama models, for example. I can't really explain that besides the pre-training data, but
Yeah. And it's one of those things you really only get insight to that with just building intuition, playing around with it, experimenting, and just kind of seeing what happens when you go through these different iterations.
Yeah.
One thing you mentioned before was there was a Qwen 3 vision model where when it was fine-tuned could outcompete Gemini. Could you talk about that one a little bit?
Yeah, definitely. This is a ongoing project that we're doing with a client, and these vision language models are interesting because in the context, you have both vision tokens and language tokens. And so it's kind of like mixing the modality before you go and generate the completion. And so that one makes it hard to prompt engineer if you have like a very specific thing that you're trying to extract and you're just trying to like describe the thing that you want to extract. So they're like it's a product catalog where they're reading the labels on things and extracting logos and just like segmenting it out. And it's like a pretty complicated vision task that would be really hard to like type out what you're trying to do. Or you could try to give it some like reference examples in the prompt itself, but then that just like blows up the context window really quickly because the image tokens are much larger than language tokens in terms of the types of things that you're trying to encode there. So we ran an experiment on their pretty complicated task with Gemini and with Qwen 3 VL, which Qwen 3 VL has a few different model sizes in there. It has like a 2 billion parameter, it has a 4 billion, it has an 8 billion, it has 30, and then I think it has all the way up to like a big MOE with 235 billion. We targeted the 8 billion parameter model, and it only took $1 to fine tune on their data set because it fine tuned in like less than an hour. And what came out was the Gemini 3 Pro got 82% accuracy on the task, and then this fine-tuned Qwen 3 VL 8B got 88% accuracy, so bumped up the accuracy. And then the crazy thing is the throughput of this model and the like GPU requirements are 100x. So if you're cranking through an entire product catalog and you have very specific things that you're looking for, it's kind of like the reverse of the image generation problem. It's the image understanding problem. They can just crank through way more data for cheaper and have a higher accuracy with this Qwen 3 VL. The last thing that I would add to that is they even tried fine-tuning Gemini on Google's platform. Like they have a way that you can fine-tune Gemini 3 Pro. And it took like $200 to fine-tune that model. And it gave them worse results because I guess it's just like a bigger model and they don't spend a lot of time on their fine-tuning pipeline. So he was like, why wouldn't I train it for cheaper, run it for cheaper, and get better results? Like, it's just a no-brainer.
Yeah, it really is a no-brainer. And it's so cool to see. I've had this theory for a while that AGI, whatever we want to find as, is going to be a collection of highly specialized models rather than one big gargantuan one. I think we'll hit both, but seeing this type of change in not just performance, but cost of running it is actually going to try to shift more people that way, especially as we make up tools and services like what Oxen offers to just make it easier for people to dive in and get these results so they can, scale up their business in an affordable way.
Yeah. And I do think like we're always going to kind of bounce back and forth. Like things will get baked into the base model and then it'll be easier just to use the base model, but it'll always be slower than a specialized fine-tuned model. And then it's just this data flywheel like we were talking about of like, oh, you want a faster one? Well, just generate the data with the slower one, distill a faster one, and then you're back to the speedy version. And you see it in the coding agents too. Like if you look under the hood of Cursor or Claude Code, some of the tools that it uses, or like the re-ranker, or like very individual steps that might take a long time but could be optimized in a cheap model, they just have like the cheap model run those steps and do them really quickly, and then the big brain collate all the information once you have it, So I think there will be this back and forth always, and it'll fluctuate, and it just depends where in the stack you're optimizing for.
It's a team effort. Got to have all the components working together. You had mentioned special tokens, which help. Are there any other concepts, or I'm thinking of things like hyperparameters or whatnot, that people should do a little research ahead of time so when they do fine tuning, they have a higher likelihood of success? Or is it one of those just got to experiment and play and, learn trial by fire?
A lot of it is trial by fire. I mean, the things that I tend to tweak the most are the LoRA rank and alpha, which are just like the capacity of the LoRA and how tunable it is. And then the learning rate itself, it can be a bit finicky. So that's like how quickly you want the model to pick up a concept. And if you make the learning rate big enough, it'll learn really quickly, but sometimes it can get stuck and can't like iterate on the minutia of the data. So that's one where I tend at the start, I'll just like do a quick hyperparameter sweep of LoRA rank, LoRA alpha, and learning rate just to like get a feel for this particular model, this particular task, this combination works well. And then there's things like batch size that you can also play with that helps regularize the model a bit and drop out. So if you're seeing it overfit too much to a specific data type, you can start playing with those things. But yeah, it does feel sometimes like you're like a witch with a big vat of stuff that you're pouring in, and the more shots on goal you get to try, the better. And that's one of the ways that we've architected Oxen, is it's all serverless GPUs that you can spin up, spin down. You could like run 10 experiments at once. All the data, all the model weights get saved back to the same place with all the versions marked, so that you're not like constantly monitoring these GPUs, waking up in the middle of the night to stop them. And I really want to I feel like in web development, there's a spectrum of like you're building on Squarespace or Wix because you're like not a developer, and then you're building on Webflow because like you want a little more customization or like CMS behind the scenes, or you're writing the code yourself and you're building your own custom website. And I feel like there's going to be a similar spectrum for machine learning workflows or AI workflows, where there's going to be people who just want to prompt the model out of the gate and don't want any customization or whatever, just like prompt engineer. And then there's people who want to or need to fine tune, who are kind of in that middle camp, who maybe don't want to have the ML ops of like writing all the code, writing all the training loops, writing all the infrastructure for that, but want the benefits. And that's kind of where I see us sitting, is like unlocking that power for people who are in the prompt engineering world, but don't want to get a PhD in machine learning.
That's a great spot to sit in. And I was actually going to bring up, when you mentioned it was an 8 billion parameter model, I was like, I got a MacBook with an M4 chip in it. Like, why don't I just do this on my local? But all of the surrounding infrastructure, everything sounds like it's way above my pay grade. And it's just a lot easier where I can just spin up, like I said, run an experiment, see, hey, how does this work? Spend $1 and just get a viable output.
Yeah, totally. And the requirements for training versus inference also are a big difference. So inference on your local machine for sure can get away with 8B, 16B, maybe 32B quantized. But then when you want to train that, especially at bigger batch sizes, you need like a pretty big GPU to make that happen. But if you spin it up on a cluster of GPUs, it trains for like an hour, and then you spin it right back down, that might be $10 or something. And then you have this thing that you can run locally and deploy locally, which is pretty sweet.
I'd love to talk about a couple of the projects that you and Oxen have been involved with. There was one you sent my way, the Isometric NYC. Saw that one go nuts on the internet. Can you talk about that a little bit?
Oh yeah, that one was super cool. We had kind of worked with this engineer a little bit. He worked at Google DeepMind and actually was on paternity leave for a little bit. And he's like, what can I build with just Claude Code off the shelf and try not to write a single line of code? But he's worked at Google DeepMind, so obviously he has like a tendency towards machine learning type projects. And he was reminiscing on the early days of like SimCity or those world builder type games that you would play. And they had a very specific like isometric style of the map. Being at Google, I'm sure Google Maps inspired this a little bit, but he was like, what if we took all of the open data of New York City and tried to generate a isometric version of like a Google map where you can zoom in, zoom out, see every single building in New York City. And similar to the project we talked about earlier with the furniture, where you had to generate a lot of data, there's like 30,000 tiles, I think he ended up with in this project. And Nano Banana was hitting it like 50% of the time. So if you just like gave it a reference image of the style that you wanted and a tile from Google Maps, it could apply that style like 50% of the time. But if you're doing 30,000 tiles and trying to put them all together, a 50-50 shot on goal is never going to work. So
No.
he did that same pipeline of just use Nano Banana to get some training images. I think he only had 50 in his training data set for this to learn that isometric mapping style. Trained a Qwen image edit model, which again would have like the reference tile, the output style, and then the prompt in this case was really simple. It was just like one token of just like stylize, because you don't really need to, have a long, elegant prompt there. And then so he trained that thing. It took 4 hours on Oxen, which I think was like $12 to get him his custom Qwen image edit model. And then he scaled that thing up on a bunch of parallel GPUs to generate the whole map, stitched it all together. And all of the like stitching code and UIs and things that he made was through Claude Code. Like he didn't write a single line of code. Even interacting with Oxen, he was like, how do I get this data up there? And Claude just like did it.
It's so cool. What a time to be alive and just be a tinkerer.
Right. It's like, that's the type of art that I feel like you couldn't do without AI, right? Like, or you could, but it would just take you forever. And this was like a weekend paternity project for him. And you have this really cool piece of art.
If someone wanted to get started, you've piqued their interest, they want to start playing around and experimenting, how do they get started? What are some resources they should be aware of? How can they just get more confident just, firing up and creating their own model?
We have a series that we run, online group called Fine Tuning Fridays. And so on Friday, we have a Zoom group. You can dial in from wherever. We have people like in Germany who are drinking their beer on Friday and people on the West Coast who are just like waking up to their coffee. So it's pretty wide variety of folks. And we try to pick a model, pick a data set, fine tune the model on the data set, and just show you the before and after, try to compare it to like a base model out there. So we're not just like, you know, guessing that this is better. We're trying to show like a real world use case, and people find those sessions pretty helpful just to get a feel for what's possible. And then the other thing is try it out yourself. Like our whole platform is self-serve. You can drag and drop images and you can caption them with a LLM like we talked about, and you should be up and running in like 5 minutes to see if at least the model starts training and getting some outputs. And then depending on how big your data set is, like an hour, you'll have a fine-tuned model. So I'd say the best way to learn is try something yourself and see how it works.
Love it. It's my usual recommendation to people anyways, but I am going to cheat. I have a Reachy Mini that I have on my desk. I want it to be my little accountability buddy, something to help me out. And
Nice.
I also have some Raspberry Pis. And I think it'd be really cool having a little model running that's just taking the video feed and acknowledges when I enter the room. Should I create a data set of half empty office pictures, half mic in chair pictures, and then that's my data set, or is there anything else you should consider?
Yeah, I think that would work great for the video models. Because I actually worked on some pose estimation and built an app that was like a fitness app that was counting push-ups and sit-ups and everything.
Nice.
Like real time from your iPhone. It would just like use the camera on your iPhone and it was running the model locally there. And the one thing that you'll probably write a little code to do is just to look at the distribution of confidence that comes out of the model. And then you'll see like a peak when you're in room versus out of room. And then you can have an algorithm that runs on top of that. That's like, don't trigger, don't trigger, don't trigger, trigger. And then you don't want to like trigger again and again and again. You just want him to wave once. You don't want him to like wave. So that's like one layer that you might have to build on top. But yeah, other than that, it would work really well.
Appreciate the tip. Greg, this has been a blast. Thank you for teaching me something I didn't really know much about. Before we let you go, is there anything you want the audience to know?
Oh, man. I think just get out there and tinker. And if you want to join our community, feel free to join. We got a big Discord and that fine-tuning Friday. I just love to hear what people are building. So yeah, hope to see you out there in the virtual or real world.
Absolutely. Yeah, we'll have the links down below. I've dropped in on the Fine Tune Fridays. I think it's great, so I hope more people do as well. Thank you for my conversation with Greg Schoeninger. I really like having Greg on because he's very well versed in the space, and this is an area I don't know that much about. I spent very little time looking to image models, video models, because I'm always working with coding models or just doing the typical LLM stuff. So getting insight to how easy it is to actually make your own model tailored to your use cases was awesome to learn, and I really hope you got value in it too. Because if you're looking to do anything at scale, you'll want to get away from the APIs to control costs, control quality, and be able to run your own experiments. And Oxen is a phenomenal tool for getting that up and running. Now, we had this conversation last week, so you might have missed the Fine Tune Fridays on the model we were talking about, but I encourage you to come visit the other ones. It's a really good supportive group where there's no dumb questions, you ask whatever you want to learn about, and they dive into papers or model releases and just learn some good stuff together. And that's what it's all about. Instead of just sitting by yourself reading papers, get together with a group. They're very smart people who can help you get through the concepts if you're struggling to understand it. And it's really neat to just get exposed to this new world. And hopefully I'll see you there. Thank you for watching, and I'll see you next week.